The commercialization of genetically modified crops came about in the mid-1990s. At that time, the companies developed two kinds of products that were the mainstay for the whole business. One was insect-resistant crops, and the other was herbicide-resistant crops. The purpose of the insect-resistant crops was to put in the crop something that insects would die if they bit into the crop. And they used toxins from bacteria, Bacillus thuringiensis, a commonly found bacteria, and they took the gene out of that and put that in the crop. So the insect would bite into any part of the crop, and presumably the toxin would kill the insect, and you wouldn't have to spray the chemicals on the crop. So that was one of the main innovations. The other was to create crops that would tolerate or be resistant to herbicides. The purpose there is typically they would use herbicides before the crop was grown to get rid of the weeds. Weeds compete with the crop for resources. So if you ideally, you want to grow the crop where there are no weeds, so they wouldn't be competing for the resources of the nitrogen of the soil, etc., or even the sun. They would not compete. So if you could get rid of all the weeds and let the crop grow without weeds, there would be no competition. So in order to do this right, and allow the plant to start growing, they would have to spray a herbicide on it that wouldn't kill the crop, but would kill all the weeds. That's the idea. So they figured out how to introduce into the crop a gene and a protein enzymes that would disable the herbicide trying to kill the crop. And the herbicide could then be used when the crop was in development, which couldn't be done before because it would kill the crop. So that was the second major innovation. And those things started to be introduced into commerce in the mid-1990s. And basically, they were for improving production, improving the system of production. So it was for the farmer and, of course, for the people who manufactured the seeds, because they were convincing the farmer that you need our seeds in order to grow a crop and to get a proper yield. Yes, I use the word GMO skeptics as the term that characterizes people who have questions that haven't been answered. They aren't necessarily ideologically opposed to GMOs, but they don't feel comfortable unless some questions can be answered that they feel have not been answered. So for some GMO skeptics, they are not comfortable with the fact that these new crops are introduced without a required risk assessment. And they feel that if you put a chemical into a food product, that there's a requirement that you have to evaluate the chemical to see if the food is now going to be safe. We also have requirements that if you spray herbicides or pesticides on food, that it has to go through a risk assessment by the EPA. Under the federal laws governing pesticides. But in the case of GMOs, the decision was made in the 1990s, and by 1992 was pretty much in place, that if you put a foreign substance into the genome of the plant, if you add a gene into the plant, that's not really considered an additive, not considered an additive. And they declared that any gene entering the plant would be considered generally regarded as safe, which is a technical term. Generally regarded as safe, it means grass. That was introduced into the law for certain types of chemicals. So when the law was passed in 1958, Congress said, oh, well, we want to give certain chemicals a free pass because they've been used for 100 years. So you don't have to put vinegar and go through the testing of vinegar to see if it's safe because, so they call that generally regarded as safe, grass. So here are these foreign substances that were going into crops that the government decided to call generally regarded as safe. And they said, well, we'll allow the corporations who produce the seeds to evaluate them, but we're not going to require that they be evaluated. If they want to consult with us, that's okay. We'll give them our consultation, but they can introduce it onto the marketplace without our evaluation. And I think skeptics are rather concerned about that as a system of protection. The Europeans have a very different system. They require that you have testing for new crops that come into the marketplace. So that's another concern about the skeptics. And also the skeptics feel that if there's going to be public confidence in this technology, that there has to be reputable, independent scientists doing the evaluations. That you don't trust, let's say, Boeing to be the only company to evaluate its planes. You want other people, independent people, to evaluate it. Or you don't want to evaluate automobiles just having the companies do the evaluations. You want to have independent people doing the testing, which we do in this country. Well, most of the evaluations now that have been done in the United States have been done by the companies that produce the seeds, and that concerns a lot of people, what I would consider the skeptics in this. So that gives you an example. And when they do hear about a study that was done, which shows that there might be some adverse effects, they don't understand why the study is left behind, pushed aside, and not really addressed by doing repeated studies or expanding the study, but not just putting it in a drawer saying, oh, this study doesn't mean anything. So that's another area that the skeptics, I think, have concerns over. Well, first of all, when you grow a corn crop or a soybean, if you grow it in different areas of the world, because of the environmental factors of the soil, of the sun, of pollutants in that area, you're going to get a variation of what's going to come out of the crop. So there will be natural variations that you get depending upon where things grow. And some of those variations might include more different kinds of nutritional profiles. So it's good to know what the natural variations are of any particular, what I would consider naturally grown crop. Now you come in with a GMO, where they put in a complex set of genes for the crop to do something that they want to do, maybe resist insects, okay? And there's a term that they use called substantial equivalence, that they are confident that these genetically modified crops are substantially equivalent to the natural crop. But in order to really determine if it's nutritionally equivalent, you have to test it. You have to look at the profiles of the two crops. People have been doing that, and it's clear that some tests have shown that there are differences in the crops. Some crops have higher potassium, some lower potassium from the genetically modified crops compared to the non-GMO crops. There may be different sets of amino acids. The levels might be different. So you can't know this unless you actually go to the crops, to look at the non-GMO, look at the GMO, and do a profile. No regulatory agency currently is required to do that, certainly not in the United States. Now, some of the manufacturers, maybe they do some of it, but again, it's not done by independent investigators under an agency head. So the short answer is yes, you could get nutritional differences. You can get differences in toxins that might be very, very small amounts, which might be increased when you genetically engineer the plant. And that's because when you put a gene into the plant, it could do other things. It doesn't just do what it's supposed to do, like make a toxin for an insect. It might destabilize another set of the genes in the plant. They interact. It's like an ecosystem. It's not a Lego system. So once you understand this and you say, okay, how do we figure out whether or not when we add this gene complex into it that we are not getting a different nutritional profile? No way to do this unless you do extensive testing to see what the profiles of those two crops are. When the commercialization of biotechnology began in the early 1990s, the industry had convinced the Congress that these things were going to be inherently safe, that traditional breeding, which is taking two crops and merging them together in different ways, is no different than what the scientists were doing in their laboratory, which I call molecular breeding. So there's traditional breeding where the natural world is unoperational, and then there's molecular breeding where the scientists are in their on their desks, on their bench tops, taking genes, splicing them, and putting them together in ways that could not have been done naturally. You can't take a gene from an Arctic carp fish and put it into, let's say, a potato and expect that to happen naturally. It's not going to happen naturally. The potato and the Arctic carp are never going to mix their genetics. It can only be done by human intervention. So the question is whether or not that process of human manipulation of the genetics of the crop is going to produce adverse effects that would not have happened if two plants had, exchanged their genetics in a natural way. And that's what risk assessment is supposed to find out. But initially, Congress was convinced that this new form of breeding, molecular breeding, was going to be as safe as the traditional breeding, without doing all the studies and the risk assessment that was necessary to be done. So that's part of the background. It was a great public relations campaign that Congress bought in the establishment of the regulations for overseeing biotechnology. They never created new laws. They used the chemical laws, the existing chemical laws, or some of them, to look at biotechnology, and they didn't really fit because chemical changes and these kinds of changes were very, very different. When this was genetic engineering of crops was introduced first to the public was told that it was more precise than natural breeding, that you shouldn't worry about it because the scientists had it under control. What the public was not told was that when you introduce these genetic complexes into the genome, into the embryo of the plant, that you cannot predict exactly where it's going to go in the chromosome of the plant. And it turns out that it will behave, the genetic component or complex that you put in will behave differently depending upon where it lands in the chromosome. So it's a bit of a crapshoot where it ends up in the chromosome. And then the molecular breeders have to try a few things and say, yeah, this one looks like it's working well, this one isn't, we'll throw that one out, we'll use this one. So they make the choices about which ones they want to use. But the idea that it's so precise is completely a created concept to assuage the public that they're in control, they know exactly what's going to happen. Unintended effects are part of the process. You simply don't know what these effects are unless you fully evaluate your product. And I would say that the biotech industries would argue, most of the unintended effects are not significant, or the molecular breeder, in other words, the industry, they would root out any bad effect. They could see it. They would make sure that that doesn't get on the market. Well, that the public has to depend on the manufacturer to root out any adverse effect. And that's not generally the way we deal with new technologies, giving the manufacturer, the developer, the power and the control over what's an adverse effect. Are they going to be looking for the effects that public interest scientists would look for? They're eager to get the product designed to do what they want to do, namely to resist herbicides or to resist pests. That's their main thing. So what if the product has a little higher toxin rate? Or supposing it has some nutritional values have gone down. That's not so important. I mean, look what they've done to some of our food. They've created tomatoes that don't taste, but they're terrific at not being crushed during delivery, or they look nice and red. So, the manufacturers have something that they want, a tomato that can travel 1,000 miles without being crushed. Okay, taste was not their big factor. So how are they going to be evaluating these GM crops? Are they going to be thinking about taste? Are they going to be thinking about nutrition? That's something we just don't know. Well, in the United States, there's no mandatory requirement that they have to be studied. But the other thing that the public has to understand is that there's no standardized testing. Nobody has developed a set of tests that say, these are the tests you have to do for this product to be evaluated as safe. And that's been stated in the scientific literature. Scientists say, we don't even have a standardized test. People are doing tests, and they are publishing the results of the tests, but let's face it, no organization, no international organization, no national organization has said, here are the tests you have to do to evaluate whether it's safe. Recently, the National Academies of Science has set a framework for such tests, but it hasn't been adopted. And it's only a framework, basically. They don't give the details of how to do the tests. So in the United States, certainly it's not mandatory. There's no standardized test. In Europe, there's a set of guidelines about animal feeding studies. So they do have something that has been at least adopted by some of their agencies. And the Europeans are doing more of those studies than the Americans are doing. And they are obviously far more cautious about accepting any product unless they have at least fulfilled the requirements of their testing. Well, all the evidence we have from USDA, they produce probably the best data on this because they collect it from farmers, suggests that about 90%, which is enormous, which means if you go to a restaurant or if you buy anything that's been packaged in soybeans and corn, it's very likely to have been from genetically modified soybean and corn, because so much of it is produced that way in this country. So the data suggests that about 90% of it, and there's only one way to reasonably guarantee that you don't get the GM soybean and the corn, and that is to buy food that is labeled as organic, because the organic standard says it can't be bioengineered. That's the standard. And unless somebody is getting it through the back door, that's the only way we know that there's no bioengineered corn or soybean in the food that we're getting. For those two products, we almost have a complete monopoly of the GM products in the American food system. And countries that have been more skeptical about GMOs will not trade with us. They will not buy these products from us. We're not the only country that's producing this massive amounts of GMOs. Also, Argentina is a huge producer of soybeans and using GMO soybeans. So it's not only the United States. Well, first of all, long-term studies are rather new. So it's only been a few years that they've been doing it. Mostly this early studies were 90-day rodent studies. And they're really designed to see whether or not the animal is going to keel over. I mean, where you get an acute effect in 90 days. So the equivalent would be if you give a human the food and within a month or so, they will have a dramatic effect. So the long-term studies are sort of the life of the animal. So that would be about 2 or 3 years. And those studies really didn't begin until about 2012. So 1996, the first products come out, and 12, 14 years later, people start doing the long-term studies. And, at least one long-term study came out with some adverse consequences, and immediately the scientists who were involved were marginalized, saying they don't know how to do studies, etc. They used the wrong rats. Didn't matter that Monsanto used the same rats that they did when Monsanto produced studies to say it was safe. So we really don't have, first of all, we don't have a agreed upon type of study to do long-term studies. And secondly, there have been very few of them done, so we really we don't know. And the one study that was advertised, advertised in the media, a large number of members of the scientific community have dismissed it as being irrelevant or a bad study. And the National Academies of Sciences put out a 550-page report, one of their best. They've done a number of reports. This is the most systematic. It covers a lot of literature. They don't have confidence in whole food studies on animals. No confidence. So they put forth a different approach, which is detailed study of all the proteins, all the metabolites, everything in the crop, compare it to the non-GMO, and that's where you'll get your best information. Nobody's doing that. It's expensive, and animal studies have been the traditional way to evaluate new products. That's the way we evaluate chemicals. That's the way we evaluate drugs. So if you're going to find some chronic effects in the animals, all of a sudden, if you start giving the animals these things and you look at the life of the animal and you find out, hey, this animal developed diabetes, after 2 years, and the controls didn't, then you have an idea that, hey, this might have some chronic effects that you can't get from these other types of studies. But so you either have some groups that don't really have confidence in animal feeding studies, and then the other studies are not being done by anybody. So it's kind of confusing because there's no standards. Yes, because you can move genes around across any species, you have possible technological innovations that you could never have imagined. So, for example, we breed crops for the purpose of human consumption, for providing nutrition to people. But all of a sudden now, we can use crops to make other products, namely not necessarily designed for consumption. Or let's say we can put into crops genes that produce proteins that might be good for making products that are not used for consumption. Or the farmer crops are designed to put into the crops a pharmaceutical. That's why they're called pharma crops. So let's suppose you wanted to produce an antibiotic, and typically it's done in laboratory conditions, and it's synthesized, or they'll take a natural substance and they'll modify it, etc. But they do this under the laboratory. But if you can get a crop to produce something that you would ordinarily produce in the laboratory, you have a cheap way of making a pharmaceutical, if it works, right? So, and there's two approaches. One would be if you can produce a pharmaceutical in corn, then you harvest the corn and you extract out the pharmaceutical from the corn, and then you bottle it and ship it out for people. Okay. That would be one way. Another way would be if you had a pharmaceutical and you wanted to put it into a banana, instead of giving a person a pill, you might say, here's a banana. Take the banana and you'll get an antibiotic. We'll call this an antibiotic banana. Okay. So what's the implications here? First of all, where do you grow the stuff? Because you don't want to grow this stuff anywhere near a regular crop, because all of a sudden you'll be going and buying a banana, and it was contaminated by a pharma banana, and now you're eating a banana with an antibiotic. So you don't want to do that. There's got to be a real sequestration, and maybe producing these pharma crops in greenhouses, but certainly you don't want the pollen of the pharma crops going, everywhere. So, and I don't think I know of an open field of pharma crops in the United States. I'm not aware of any. But anyway, it's on somebody's agenda because they pop up every once in a while, these pharma crops do. And they also have animals that they put a gene in. So I remember my university had a transgenic goat, and it produced a pharmaceutical called tissue plasminogen activator, TPA. And that chemical has been used and is used as a way to prevent blood clots in people. So while they do have it from laboratory, they thought if they could get the goat to produce it in its milk, they would have an easier way to produce it in an animal, and then extract it from the milk and give it to the patients. So, so this goat was a very expensive goat, but as far as I know, I don't think they are extracting pharmaceuticals from transgenic animals today, but it certainly has been on the radar screen of investment companies. I should also say about sequestration that in Europe, there's a lot of concern about separating the planting of GMOs from the planting of organic crops, because they don't want the GMOs to cross over and pollinate, and they have strict rules about separation, which we don't have in the United States. So we have no strict rules. So somebody who plants a GMO crop, a mile down, there might be a non-GMO crop or an organic farm, and the pollen may contaminate the organic farm, and the organic farmer may lose their license or their authenticity as an organic farmer because they've been contaminated by GMOs. And there has to be strict sequestration rules so that the organic farms can be protected. Because the studies are not mandatory in the United States, and because there's a large body of entrepreneurs as well as scientists who feel they're not warranted, there is no government funding agency that funds such studies. It's extremely rare. So the major funding for studies of this nature in the United States is the companies. The government has no interest in funding these studies because the national academies have said it doesn't make a difference whether you do it naturally by natural breeding or by molecular breeding. You could get some hazards from natural breeding. It's true. We have bred certain potatoes that have higher levels of a certain toxin, and the breeders fortunately figured that out, and they don't commercialize those potatoes. So they say, you could get toxic effects from natural breeding, you could get toxic effects from molecular breeding, and we don't regulate natural breeding, so we won't regulate molecular breeding. So we're not getting any funding for that kind of research in the United States. Mostly it comes from companies, unless somebody has private sums of money or a foundation is willing to support it. In Europe, the European Union does fund such studies. So you see a lot of studies done in countries like Greece, in Turkey, and various countries doing health studies, animal feeding studies, because they get funding from the European Union. If you knew exactly what you were looking for, maybe it wouldn't be as difficult. When you study chemical, it's also hard. So we usually use animals to study chemicals, the toxicity of chemicals. There's a lot of endpoints. That is, you could be looking at whether the chemical is a carcinogen. So you look for tumors. You could be looking for whether the chemical is what's called genotoxic, whether the chemical affects the genetics of the animal, whether it mutates the genes. It's called genotoxicity. You could be looking at whether the chemical affects the brain. That's called neurotoxicity. You could be looking at whether the chemical affects the hormone system. So that's called an endocrine disruptor. So even with, with a chemical, you know what to look for, and you can get your experimental animal in your control, and you can see whether or not you see any of these effects on the experimental animal that you don't see on the control. With the GM food, you don't quite know what you're looking for. There's a lot of things that could happen. You could be looking at nutritional levels. You could be looking at whether there's a change in the toxicity. You could be looking whether a new protein, something that you even didn't imagine, emerges with new properties that you couldn't have even imagined. So you don't quite know exactly what you're looking for. So some of the people who do these experiments, they kind of looking at the total picture, seeing if they see anything that seems reasonable. So one study looked at genetically modified corn, and they looked at the gut of the animal that they studied, and they found abnormalities in the digestive tract of the animal that they studied. They were looking for something, and they could see in parts of the digestive tract that there were abnormalities in the tissue compared to the controls. So they were able to do that, and they did conclude that the GMO produced those abnormalities and the non-GMO did not. Now, did anybody care about that study? I don't think so. That study didn't appear in the front pages of the newspapers, and all of a sudden the government agencies, no, it was just one little study. So it's not easy to do these studies, and if you do them and you get a result, you're not necessarily going to get a supportive community behind you saying, hey, this is, we ought to follow this up, or what implication does this have on humans who eat this stuff? So that's the problem, I think. No single study is going to reveal something that people will look at and say, oh boy, this is a critical study. We better stop producing this product. First of all, it's extremely difficult to prove something is safe. If you want to prove a product is safe, how do you prove something is safe? Well, it's very hard to prove it because if you do one test and it's safe, it might not be safe in another test that you do. But in order to get confidence that something is safe, let's say an airplane or a car, you test it under extreme conditions. You try to imagine what's the worst case scenario. If it survives the worst case scenario, then we'll have confidence in it. If you test it under the best conditions, you've not really given people confidence that it's safe. So you have to test the plane, for example, in conditions where there's turbulence, or there's rain, or there's lightning, whatever. And, can it go through a lightning storm? That's what you want to know, or how will it deal with when there's extreme turbulence? Will it break up, or will it hold together, with all of its pieces hold together if it's shaking? So you test it under the most difficult conditions. That's the only reasonable way to get confidence that something is safe. I don't think we're seeing that approach to GMOs. To do that, you have to have an imagination of what could go wrong when you introduce these foreign gene complexes into the system. What other genetic components in it could be activated that would change the product. And if you can imagine such a system, then you'd have to try to test it under those circumstances. So it takes a certain amount of creativity and imagination to test something and get confidence in its safety, and not just do a simple test that the company might say, oh, well, we just fed it to these animals, and in 90 days we don't see any problems, therefore they're safe. That's not going to give confidence to many people. Well, there were a series of studies done by a group in France, and it got a lot of publicity because the studies had an adverse effect. And any study that produces an adverse effect is likely to have more publicity than studies which say it's safe, especially when the studies that say it's safe are supported by the big seed producers. So in a reasonable world, when a respected scientist reaches a conclusion that the product is not safe, other people will repeat the studies and try to get to see how they got those results and whether they can replicate the results. Replication is a very important part of science. If you can't replicate the results, then what's going on? Why did one person get it and the other person not get it? So what I'm finding from looking at the literature is that there is no effort to replicate studies which show adverse effects. And in my own investigations, I found at least 26 studies that had these are animal feeding studies, that had adverse effects. And I cannot find any replication of this or any government agency that says, well, we've got to take these studies very seriously and we've got to start putting money to see whether or not we are going to be getting replication of these studies. So to me, that's an important problem in bringing the public confidence around a new technology, is to have replicated studies. But certainly the group in France have done studies that no one else has done, and they've found some adverse effects, serolini, and they've been mistreated by the rest of the scientific community. One paper was retracted from a journal after it was peer-reviewed and approved by the reviewers, after a year of pressure by Monsanto, and it was pulled out of the journal, not because there were mistakes in it, not because there were violations of ethics, but because the results were not definitive, according to the journal editor. That's a very unusual reason to retract a paper. So I have to assume, as a scientist, a social scientist, that paper was retracted for political reasons and not for scientific reasons. We have a lot of experience with products from corporations that have been advanced by funded research from those corporations. primarily the tobacco industry has set up its own non-for-profit research institutes to show that secondhand smoke was safe, tobacco was safe. We've had similar institutes set up by the lead industry to show that lead was safe for many, many years, prevented lead from being removed from gasoline, from other places where children consumed the lead. So we have a lot of experience with how corporations try to protect their products by influencing the science. And the same is happening in this agricultural biotechnology industry. And the best way we have to learn about the practices of corporations is through the documents that are filed during litigation. So when the tobacco industry was litigated by the attorney generals from a number of states, they had to produce discovery documents. These are the documents that the court requires them to produce so that the plaintiff's attorneys can see what's going on, what the company is hiding or not hiding. So these discovery documents have now been revealed in Monsanto's case. And those documents reveal corporate malfeasance by the company in trying to influence the science behind risk assessment. And the more we learn about it, the more we realize that this is a real phenomenon in biotechnology, as it was in the tobacco, in the tobacco litigation and the lead litigation, which has revealed much about the way in which corporations try to influence the scientific community. I'm of the opinion that molecular breeding is not necessarily all bad or all good, that there could be some uses of it which could meet a rigorous assessment of its value and risk. And my research has looked at certain of these products, and one of them is a method for activating the plant's immune system to resist viruses. Now, plants, like humans, have an immune system. And we activate the human immune system by the use of vaccines to resist viruses. And you can do the same thing with plants. So, especially in Hawaii, they had a terrible outbreak in the papaya industry of ring spot virus. And somebody came up with the idea of activating the plant's immune system and allowing the plant to develop its own resistance to the ring spot virus. So they used biotechnology to activate the plant's immune system without putting in foreign proteins, without putting in new, in a sense, new properties the way they would with herbicide resistant or insect resistant. And I believe that so far that has proven to be a successful use of biotechnology and not without any hazards that I've been able to determine. So that would be one way you can get biotechnology to help out. Now, as far as golden rice, which is the biofortified rice, the concept, for some people was a good concept. We we fortify our food all the time. You buy milk, it says fortified with calcium, vitamin C, or calcium, whatever. So they just add that to the product. Question is, can you add something to the genome of the seed so that when we eat the plant, when we eat the rice, we're getting vitamin A, which we ordinarily would not be able to get much of at all, that we could get a more complete diet. And for people living in certain regions of the world where they don't get access to green plants with vitamin A, that they could get the vitamin A in the rice. So the concept is a reasonable concept, although some people would say, don't try to put all the nutritional value in one plant. They should be given the opportunity to grow spinach and place so they can get a full range. But anyway, meanwhile, there's a lot of children dying, or at least without vitamin A, they go through blindness. So the concept was a good concept. They've been working on this for 18 years. In 1980, Time magazine had the front cover devoted to the person who invented golden rice. But it's not ready for prime time. And there are reasons. It's either not safe enough yet, proven safe enough, or it's not effective enough. You have to eat too much of the rice. So it's still in process. Maybe it can be done safely. I wouldn't want to predict one way or the other. But if you can save children from blindness by some biofortification method, I'm all for it, as long as it's proven safe and not harmful. Well, it's an interesting question. How does the mainstream media take a position on GM food? And you have to understand that the health scientists and the science writers in the mainstream media have generally come from some of the better communication schools, and they have a great confidence in good science, as they should, But that means that they would typically respond to maybe 6 major journals that they read, and these journals are aware of that, so they write to these leading American journalists. So the journals are Science, Nature, The Lancet, the British Medical Journal, JAMA, the New England Journal of Medicine. Those were the preeminent journals, and as soon as they come out with an issue, they send the issue to the major journalists, and that's why those journals get the publicity that they get to. And also, when the National Academy comes out with a report, they have a publicity arm of the Academy that gets the attention of the science journalists and the health journalists around the country. So that's how the system works. And any person who publishes in science journals knows that if they publish an article in one of these 6 journals, they're going to get publicity. They'll get a feature story in the Times. And if they don't, it's much harder. It's not impossible, but it's much harder. So much of the mainstream media is going to follow what they appears to be the consensus view of the scientific community. And that consensus view comes out of these journals and comes out of the National Academy. So if the consensus view in the United States is that GMOs are perfectly safe, there's no evidence that there's any harm, then that's what's going to be reported in the media. And it takes an enormous amount of effort and other kinds of scientific studies to disrupt that position. That's the standard position. And when the National Academy issued its 500-page report in May of 2016, that was basically their position. Even though the report had many nuances, the media picked up on its primary position, which was encapsulated in not the 550 pages, but in 1.5 pages that they sent to the major media, which is that there's no difference in the risks from traditional crop breeding to this new form of molecular crop breeding. And that's what the media picked up. So there's a good reason why the mainstream media presents the issues the way they do, because it's coming out of the major scientific and medical journals in the United States. They therefore will not pick up on a study published in a good journal, but not the leading journal, that says something different. It takes a lot to get their attention to those kinds of issues. So I once did a study of conflicts of interest policies in journals. And after the study was done, I pitched the study to one of these 6 major journals. I thought it needed to get attention. And I couldn't get at least one of the major journals to take it. They didn't even send it out for review. So my colleague and I published it in a bioethics journal, which is not something that is read by the leading science editors. So I sent a preprint of the article to somebody in the New York Times. And she brought it to her editor and she said, we're gonna do something on this. And the night before it came out, she called me up and she said, this is a very well-known New York Times reporter. And she said, Dr. Krimsky, you know, we think the article is really important and good, but we have to ask you, why did you publish it in this journal? In other words, why didn't you publish it in the New England Journal of Medicine or in JAMA, et cetera? And I said to her, and I have to say, I wasn't totally honest. I wasn't going to tell her I pitched it to another journal, but I did say, this is an article about journals, medical journals. So why would I want to publish it in a medical journal? And she got it immediately. Of course. Well, and it got the story in the Times. And it was an important study, but it wouldn't have been accepted as important if it didn't get the imprimatur of a major news source. So it's a tricky business. You can have a good study, but if they don't think that it's it's ready for prime time in the major journals, then you might not get any attention. That's how the media works. Yes, I think they were smart enough to realize that the data in the study was very unique. Nobody had ever done it. And that was very valuable data for people to understand. And you can't always get your data to be published by these 6 top places. And but I noticed that the media attention you get is directly correlated to whether you can get it published in the top journals. And of course, everybody tries. And then, of course, that's why they have such a high rejection rate. And that's why they're considered so good. Because if you reject so many articles, then you're considered the hardest to get into. So it's an interesting cycle. But I respect those journals regardless. They have high standards, and they should. And whenever I get reviewed, I respect most of the reviews are respectful and honest, and it's the best system we have. It's not perfect, but better to read articles that have gone through reviews, because at least other independent voices have looked at it and given their recommendations on the piece, and that's a good thing to do. Wow, there's a lot of issues in that one question. No, I certainly don't think it's the most important agricultural technology that was ever invented. I think when ordinary farmers figured out that they could take a pollen from one plant and put it into a slightly different species and get a crop from it, that was a pretty powerful technology. Very simple, but they discovered it 1,000 years ago, that they can start crossbreeding plants that produced a cornucopia of new products. I don't think the public has yet gotten more flavorful, more nutritious products from biotechnology than has been achieved for thousands of years through other methods of traditional breeding. None of the products that have been produced, I would consider, are designed to improve the quality of the food for consumers. They're designed to help the producers produce, a better yield perhaps, to ward off insects or whatever, but certainly not focused on the quality of the food. So my answer is no, it's not the greatest technology that's ever been invented. Now, the next question is it the way in which we will eventually solve the problem of world hunger? No, it's certainly not. I've been reviewing very carefully the science of yield and how yield is determined and whether or not biotechnology is correlated with higher yield. And it's not necessarily correlated with it. There are cases where the yield increases and cases where it isn't. It's a very iffy prospect. Yield largely is affected by environmental factors, where you grow the food, the soil conditions, the water and other conditions, there are situations where yield has improved for a while until the insects have become resistant to the insect-resistant crops. And then the yield starts to decline. So there is no systematic increase in yield. And even in this monumental study of the National Academies of Science, they say there's no evidence that thus far, that this technology will solve the world's food crisis. It's just not designed to do that. It's not like, all of a sudden producing yields that are, unheard of in terms of their prolific character. It's just not something we find yet and may never find with this technology. The yield varies enormously from conditions of growing. And biotechnology is not the factor that determines the yield. As a matter of fact, if biotechnology in some of these crops reduces the quality of the soil, as in some cases it might, then that could reduce the yields, because the richness of the soil and its nutrient components will improve the yield. And if that is declined because of some of the products in biotechnology, such as the use of herbicides constantly infiltrating the soil, then you will have a negative outcome on yield. So there's no consistency one way or the other on yield in biotechnology. Its primary purpose is not necessarily to create a greater food supply for the world, but it's to create economic benefits, both for the farmer producer and for the seed producer. Those are the two primary economic benefits that they're looking at. Certainly not to produce food at cheaper value for the consumer or better quality food for the consumer. I remember when they produced this bioengineered tomato. Very early in the development of biotechnology, they had the flavor saver tomato. And its purpose was to produce a tomato that you can actually pick red, ripened, and transport without it getting soft. So it had to have some kind of genetics in it that would delay the ripening process. And it worked. I actually bought a box for my class, and I tested it, and it took a much longer time to ripen. But it didn't taste very good. I mean, I wasn't getting any, I wouldn't necessarily buy it just because it could last longer on my shelf unless it had a really good taste. So that whole technology failed. We don't see a bioengineered tomato on the market now. And they couldn't get all the things they wanted and also get the taste that they wanted. But the primary purpose of it was so that they can transport it long distances and it would still remain without softening. That was their primary purpose. The FDA is in charge of labeling food. And they have a provision for mandatory labeling, which is good. How much sodium is in food, trans fats, etc. It's good. I look at those labels. And then they have voluntary labeling also. Halal, is it, do they kill animals when they're catching tuna, etc.? So there's different kinds of labeling in food. And they decided that because they believe that genetically engineered food is no different than traditional food, that there's no requirement for them for mandatory labeling. As a matter of fact, they would oppose mandatory labeling because of there has to be a substantive difference in the material components of the food for there to be labeling. So FDA refused to label the food under their laws, under their regulations. So then the states started passing their own labeling laws. Well, the food industry was concerned that there would be a patchwork of labeling laws. California has labeling for certain chemicals that other states don't have, and you'll often see a label that says, this substance is considered as a hazard in the California state, under Proposition 65, whatever. But it'll have to have a label if they want to sell it in California. And we in Massachusetts will see that label. So the biotech industry did not like the idea that states were beginning to label the food, and Vermont was further along on that. They were ready to implement its labeling law when Monsanto had lobbied the Congress to pass a national labeling law that would preempt any state from issuing a labeling law. So now the Congress passed a labeling law for GMOs, which has not been implemented yet and is very vague about how the food will be labeled and which foods will be labeled. You may have to call a number if you want to find out. You may have to have a special kind of app on your cell phone and shine it in front of a tag on a thing. I can't imagine a lot of people would be doing something too difficult just to get the information, but it's a cumbersome, not clear labeling law that has yet been put into practice. I don't know when it will be, but it actually preempted a simpler, more direct labeling law that was going to be put forth in Vermont, and which passed it was litigated by Monsanto and actually met the court's criteria when it was tested. So it was ready to go. But now we have a national law, but nobody has yet seen it in operation or know how effective it will be.